The box that the recording electrode leads are plugged into is attached to the amplifier. The amplifier in this setup is a 4-channel amplifier or a quad amplifier labeled 0, 1, 2, and 3. The bicep brachii, which we place the leads of the electrodes into the 0 connections, sends the signal from the muscle into the amplifier labeled as 0. The box with the leads attached to it is attached to this big amplifier in the section labeled electrodes. The amplifier is connected to the 8D board. The 8D board stands for analog to digital. This means the electrical potentials we are recording from the muscle is an analog or biological signal. For the computer software to recognize this analog signal, it must be converted to a digital signal of zeros and ones. To do so, the output from our quad amplifier from channel 0, for example, is directly connected to the ADC input labeled as 0. The tricep brachii, which would be attached to channel 1 in our amplifier, goes to channel 1 on the A to D board, and so on. The A to D board also has DAC outputs, DAC outputs. This is the digital to analog converter output. The trigger connection is used when you want to trigger the software to begin recording based on an external signal. The external signal commonly utilized in our lab is on the cycloergometer using a magnet system. For example, when arm cycling, if we want to trigger the software to begin and to elicit a nerve stimulation, for example, we can set up the magnets to set this trigger to occur at any position during this arm cycling movement. Typical positions that we trigger from are currently the 6 o'clock position relative to a clock face when arm cycling, or the 12 o'clock position. So if we think of the bicep brachii during arm cycling, it is an elbow flexor and will be contracting, pulling the handle towards you at the 6 o'clock position when the elbow is flexing. Conversely, at the 12 o'clock position, the triceps are very active and pushing the handle away from the body. By triggering the software to deliver stimuli and to record potentials at either of these positions, we can thus assess corticospinal excitability when the muscle is very active, the 6 o'clock position, and when it is relatively inactive, the 12 o'clock position.